In this video, we're going to talk about the slope of a line. Now, the slope of a line is a measure of the steepness of that line. Now, in this picture, I've drawn a line that goes through the points 2, 5 and 6, 12. And the question is, what is the slope of this line? Well, the slope of a line is defined to be the rise over the run. So what that means is that if you take any 2 points on your line and you calculate the ratio of the rise over the run, then that will be the slope. Okay, now the run is the horizontal distance between the 2 points, and the rise is the vertical distance between the 2 points. Okay, now in this case we have the point 2, 5. The x-coordinate there is 2, and the y-coordinate is 5. And the other point is 6, 12, so let's draw the x-coordinate and the y-coordinate. So what is the run in this case? Well, you notice that the run is the distance between 2 and 6. Okay, you have to run from 2 to 6. And so what is that distance? Well, of course, it's 4. Now, how did we get 4? Well, we just do 6 minus 2, that's 4. Okay, and the rise is the vertical distance between the 2 points. This point has a height of 5, and this one is at a height of 12, so the rise is going to be 7. Okay, and again, that's really 12 minus 5, which is 7. So the rise of a run would be 7 over 4. That's the slope of this line. Now, in a more general situation, if we have a point x1, y1 and a point x2, y2, how could we find the slope of that line? Well, this point x1, y1, the x-coordinate is x1 and the y-coordinate is y1. Okay, just like in the previous example up here, we had 2, 5. The 2 was down in the x-axis, the 5 is on the y-axis. Okay, now x2, y2, let's do the same thing for that point. Okay, now the question is, what is the rise and what is the run? Okay, what is the rise? Well, the rise is going to be the vertical distance between these 2 points. Basically, the distance between y1 and y2. Well, how do you find that distance? You just do y2 minus y1. Just like up here in this example, the distance between 5 and 12 was 7. Okay, we did 12 minus 5, that gave us 7. So this is going to be y2 minus y1. And similarly, the run is going to be x2 minus x1. Okay, that's the distance from x1 to x2. Okay, and then the slope, which is rise over run, would then be y2 minus y1 over x2 minus x1. Okay, so that's the general formula. So if you don't have specific numbers for x1 and y1 and x2 and y2, this is the general formula for the slope of a line connecting these 2 points. Okay, and I've written this out here as a definition. It's actually a definition that the slope of a line between the points x1, y1 and x2, y2 is y2 minus y1 over x2 minus x1. Okay, let's do a few examples. Part A, find the slope of the line that goes through the point 1, 2 and 4, 6. Now, you don't actually need to draw the pictures in order to do this, but I want to draw the picture just to kind of get a feel for what's happening. Now, 1, 2 is about here somewhere. 4, 6 is about here. Just do a real rough sketch of the graph. Okay, and the question is, what is the rise and what is the run? Now, just according to this picture, you can see the rise, it's going from a height of 2 up to a height of 6, so the rise is going to be 4. And the run, if we're going from 1 all the way over to 4, this is going to be 3. So we can see that the rise of a run is going to be 4/3. Okay, now I don't want to do this every time, drawing the picture every single time. I want to actually apply the above formula. So to apply the formula that we had up here, we need to call one of these points x1, y1, and the other point x2, y2. Okay, and if we do y2 minus y1 over x2 minus x1, what we're going to get is, well, the y2 is 6. The y1 is 2, the x2 is 4, and the x1 is 1. So what we end up with is 6 minus 2, which is 4, over 4 minus 1, which is 3. Okay, so you notice this 6 minus 2, that was this distance here, and the 4 minus 1, that's this distance here. Okay, we had a slope of 4/3. Now, the reason I'm going to do 4 examples is each of these examples is going to illustrate something different about slope. Now, this next example, 0, 3, is right here, and 4, 1 would be about right here. 4, 1, 0, 3. Okay, so here's 4, there's 1, there's 3. Okay, again, we have to call one of these points x1, y1, call the other point x2, y2, and let's plug it into our formula, y2 minus y1 over x2 minus x1. What we end up with is, well, y2 is 1, y1 is 3, over x2, which is 4 minus x1, which is 0. And notice what we end up with is negative 2 over 4. Now, if we reduce that, we get negative 1/2. So the slope is negative 1/2. Now, what does that mean? It means that if we go over 4 here, we go down 2. Okay, so the negative means that as we run to the right, we're going to go down. Basically, what that means about the line is that it's going to have a negative, it's going to go down as you move from left to right. Okay, so a negative slope of a line means that as you're moving from left to right, the line is going down. A positive slope means as you move from left to right, the line is going up. Okay, so this had a run of 4 and a rise of negative 2. Okay, so we had negative 2/4, or if you reduce that, it's minus 1/2 is the slope of that line. Okay, the next example, notice that both of these points have the same y coordinate. Okay, we have negative 2, 5 and 9, 5. They both have 5 as their y coordinate. So what would this look like? Well, negative 2, 5 would be about here somewhere. 9, 5 would be over here. And notice these 2 points both lie along the same horizontal line. Okay, I didn't draw that line very straight, but that's a horizontal line. So what is the run between these 2 points? Well, notice we're going from minus 2 all the way up to 9. The run is going to be 11, but the rise is going to be 0. It doesn't go up at all as you go left to right. Okay, in fact, if we plug this into our formula, y2 minus y1 over x2 minus x1, what we're going to get is 5 minus 5 over 9 minus a minus 2. And that would be 0 over 11. But 0 over anything is 0. Okay, so the slope is 0. In fact, that's always true. If you have a horizontal line, again, I didn't draw it very well here, but that's supposed to be a horizontal line, it would have a slope of 0. Okay, in the last example, notice that the x coordinates are both the same. We have 3, 1 and 3, 5. And so if we draw these points in our Cartesian coordinate system, 3, 1 be about here somewhere. Okay, there's 3, there's 1. And 3, 5 be up here somewhere. Okay, notice they both lie along the same vertical line, if I can draw it correctly here. They both lie along the same vertical line. Okay, and so what is the slope between these 2 points? Well, if we do y2 minus y1 over x2 minus x1, what we get is 5 minus 1 over 3 minus 3. 5 minus 1 is 4. 3 minus 3 is 0. 4 over 0, though, is not defined. Okay, it's not defined, so we say that the slope here is not defined. Okay, not defined. Okay, sometimes books will say it has no slope, but I don't like the terminology no slope because when I think of no slope, I almost think of a horizontal line instead of a vertical line. But we say that the slope is undefined. Okay, so the 4 things we illustrated here are that if you have a line that as you go left to right it's going up, that's a positive slope. As you go left to right, if the line is going down, that's a negative slope. If you have a horizontal line, that would be slope 0, and if you have a vertical line, the slope is undefined. So I've pointed out all these facts right here. Okay, one other thing I want to point out is that the slope of a line is independent of which 2 points you take on the line. So for example, if you have some line, It has a certain slope. Let's suppose that you've calculated the rise over run between these 2 points, and let's say the rise is always twice as big as the run. Okay, the rise here would be, let's say that the rise here is 2 and the run is 1. Well, the slope would be 2 over 1. Well, if you take any 2 points on the line, okay, maybe this point here and this point up here, maybe this time the slope, the rise over the run would be 6 and 3. But the point is that ratio, 6 over 3, is the same thing as 2 over 1. Okay, they're both equivalent to the number 2. Okay, if you take any 2 points on the line and calculate that ratio of the rise over the run and simplify it, you'll get the same answer.